All right. I got everyone's attention. Hello, everyone. Welcome to our session, our code talk on agentic code generation for industrial analytics and predictive maintenance. So I don't know if you've attended our workshop. We actually had one as well. See if hands of anyone attended a workshop we did as well. Oh, it's our fan club. It's good. So it's actually a little continuation from that. So just special for you. You'll get to see what we do here. So. All right. So my name, I'm Chris Azer. I'm a principal GenAI Labs solutions architect. So I'm part of a team where I'm a tech lead helping drive industry applications with generative AI and just showing how we can improve in operations and other types of use cases. And so I've been with AWS 8 years and doing industrial automation for 20 years. So happy to share this progress in where we're at today, right? Where this next form of transformation in manufacturing really can accelerate and create agility in being able to drive operational improvements. And so I'm joined with Raju.
Yeah, thanks, Chris. Hi, everyone. I'm Raju Gottamukala, and I'm an IoT specialist solutions architect. And my focus has been really working with industrial and manufacturing organizations in terms of helping out throughout their digital transformation journeys, right? Starting from how do you unleash data from machines using hundreds of industrial protocols, all the way to building intelligent models that can respond when there are issues with those machines. Yeah, over to you, Chris.
All right. So for our agenda, we're going to kind of just talk about some common challenges in this space. Probably if you're from the industrial world, you may be familiar with those already. We'll then jump into our AWS stack and just show you what we're going to use today, right? Which AI services, which IoT services will be used. And then going to go through a couple of tutorial coding sessions. Again, this will be code that you'll have access at the end. So there'll be a QR code. You can get access to our code on GitHub. So the first one will be around looking at anomalies and creating a repair plan around this. And then we'll look at it kind of going deeper, right, and using advanced analytics that can actually look at maybe excessive anomaly detections you do have, and really trying to look at a bigger picture through analytics of what could be an issue or relation between maybe multiple parameters. All right. So some common challenges, right? When we look at on the left here, IoT and OT. I'm sure people heard this acronym. Where we're trying to merge these two different worlds together: operational technology and information. And they operate different. They have different processes and different software and different environments. So there's a lot of challenges in this space, whether it's lack of response times, slow digital transformations because it takes a certain skill set to implement some of these latest transformations in technology, whether it's IoT or AI or digital twins. There's also this data analysis gap, a skills gap that would exist for being able to create these predictive models. And with generative AI today, we've really gotten that ability to give that to the power of many people, right? Being able to do this kind of complex analysis on time series data and really try to find anomalies or patterns that may exist. So that kind of skills gap doesn't exist in both of these orgs, readily available, right? So this can lead to costly downtimes. Just accepting that there's a downtime that happens with this machine or this vendor's machine, and I have to do scheduled maintenance more often. There's also a manufacturing skills gap. There's an aging workforce. There's people that are just not there 30 years anymore, and that kind of loyalty, right? They're leaving with that knowledge. So how do you enable that new workforce to be able to make quicker decisions and really minimize that response time, the mean time to respond to a failure? Other common technical challenges: service complexity. I'm not saying our services are complex, but just in general, there's a lot of services that may exist, a lot of different technologies, and being able to optimize the use of those services in a way that would be able to solve that problem quickly. So being able to have that learning curve to understand the services that I need to use, the SDKs I need to use, can really slow down that advancement and agility.
Yeah. So we talked about the challenges. Let me start with one of the common challenges I see with my customers, right? Is when you are in a manufacturing facility, you got to deal with different systems, different control systems, OT systems, IT from different vendors, right? So the data is siloed in most cases. So the real challenge is how do you unleash data from heterogeneous systems, and then how do you create those contexts so you can then build analytics on top of it, right? Now, and then you need a reliable data foundation layer before you can actually go ahead and create agentic AI workflows. So before we talk AI, let's talk the data foundation that you need to build the AI layer. So when I talk about data foundation layer, you need a way to collect data from machines, be it Modbus, OPC UA, MQTT, or any other industrial protocol. You need to collect the data, model the machine, store the data securely, depending on your price latency trade-offs, right? For your use case, it could be a real-time operations dashboard type of use case, or it could be some post-factor analysis that you do every quarter. And then once you store the data securely, then you need a way to egress the data from that foundation layer, right, to run your analytics. Now, this is where AWS IoT Sitewise comes into play. It's really a purpose-built industrial data service for industrial and manufacturing use cases. Essentially, it helps you with the end-to-end value chain for industrial data, starting from collecting data from machines at edge, to buffering data at edge, to intelligently publishing to cloud cost efficiently, and then storing data in the cloud, and then making it available for the AI layer, right? So one unified platform that gives you access to all the telemetry and the knowledge-based data. So we'll use this Sitewise in our tutorials today, and then show how you can build that foundation layer before we build AI agents. So with that, let's talk about AI, what we got to offer, and on top of this data foundation layer. Yeah, over to you, Chris.
Yeah. So before we get into that, any questions you may have, this is open to questions.
Yeah, this is interactive, so you can ask questions, not like workshop. Any questions on?
Okay. There you go. Yep.
So I would say probably one of the biggest things that I noticed with inside the IoT space is like Kafka is like not existent for like a transport protocol. Is that like inside the stack, or do you guys see that like more and more that Kafka is like taking over the MQTT space or that transport protocol itself?
Do you see that? You're saying that you're seeing that more than use Kafka more than
Well, no, I'm actually seeing like less and
less of it used.
It's like not dipping into the IoT space as much.
Okay. Yeah. No.
Do you see it differently, like with your guys' lens in the industry or not?
That's a good question.
Yeah, so depends on the machine, right? So, and also the throughput. So MQTT is a good fit, when you're dealing with resource-constrained devices that transmit messages frequently, but not too big in terms of the message size. That's a classic scenario for MQTT-based messages. So,
Like post-device,
yeah,
site-wide.
yes, yeah. So, yeah, that's a good question because, in fact, we are working on a few enhancements. It's still under design. But the idea here is Sitewise has all the contextualization done in it, right? Now, you need a way to extract the data. Today, we provide different ways to do it using SDK, MCP. But then one common ask is, can we extract data in a data stream format, right, to Kafka? So today, you could do it through a middleware, through IoT Core. Sitewise can emit MQTT messages to IoT Core, and IoT Core has a rules engine that can route messages to 20 other services, including Kafka. So you can do it today, but we are working on some enhancements to make Sitewise to Kafka data egress much more efficient. But there is a way today for sure that's available for
You don't see as many people doing it.
No, we do see customers, asking for it. We work backwards from the customer. Because we had customers asking for it, we are building some more enhancements. So the quick answer is, yeah, it's a very common pattern we see nowadays. How do I extract data, the contextual data, to your streaming layer? And then we are providing some more tools for you to do that.
Good question. Any other questions? We'll ask you again later. So. Okay, so jumping into the AI stack. This is probably out of date just after, yesterday, right? But we're just constantly developing in the stack, and the way you look at it, it starts from the bottom, where we have our infrastructure, right? So we talk about AI compute, whether that's, silicon like AWS Trainium and other types of Inferentia and other types of GPUs. We have Amazon SageMaker for that fine-tuning and that, data scientist layer, right? In terms of that kind of work you would be doing. We're not going to be focusing on that, right? We're actually in the middle layer, right? And in the top layer. So the middle is where you actually build and use services, configure and use services that runs on top of this infrastructure. So you're not necessarily saying, I'm going to use that chipset. I want to use this chipset, right? We actually abstract that for you, and you just use the service or software. So there's Amazon Bedrock, which is essentially this platform that handles many different capabilities, starting with your choice of models you want to access. And in this case, we're going to use Claude Sonnet 4. That's one of the LLMs you can access through Bedrock. There's other capabilities like guardrails and other things you can do, which we won't use. We're going to use the knowledge base to actually access vendor manuals and specifications that would be used by the agents later. And then there's Agent Core, right? That's where you have a variety of models you can pick and choose to use. You can decide to use runtime and run your agents there. You can use a gateway to access tools. So there's a variety of these different modules. And so what we're going to do is actually have a strands agent on the top right. That's an open source framework we have to build agentic applications. And we're going to be able to use memory from Agent Core so we can contain that memory in the conversation that someone like a process engineer may need to have access to. On the top, we're going to have an application layer using Kiro. Anyone you have heard of Kiro, I'm sure, at this point, right? This is a developer environment we have. And now recently announced an autonomous agent that can run off the IDE in the cloud. And so we're going to see that combination of services used. Ultimately, we're going to help you walk through building this application and then executing some of the code and walking through the code that we would use to perform these different tutorials. All right, so we'll start the first one.
Okay.
Over to you. You have to switch over.
Any questions before we move on to a live tutorial? And how many of you use Strands SDK today in your day-to-day or weekly or monthly? Anyone? Strands? Anyone new to Strands or?
Are some building agents? No?
Okay.
All right.
So not many. Yeah.
She's like, yeah.
We just want to make sure so we know, how much time we want to spend on Strands because, this session is not about Strands, but more on, how you use Strands and Agent Core for a specific domain use case. I'll try to cover some basics when I do that. Okay. So in the first tutorial, we'll split. We have 2 tutorials total. So probably we'll spend like 20 minutes on each tutorial. And if you have any questions, please do ask. So in the first tutorial, we'll show you how you can create a workflow, agentic workflow that is made up of 3 agents, and each with a specialty. We'll go into the details. But then the workflow, the goal here is to create a autonomous maintenance response or a repair plan when there is an issue going on with a machine, right? So the prerequisite for this tutorial, again, it's all in the GitHub repo. We'll share that in a moment. Is to have the environment ready, right? So environment, when I say is Sitewise with your assets onboarded to Sitewise, data stored in Sitewise, and to those new to Sitewise, we came up with a new anomaly detection module of Sitewise natively. So you can enable anomaly detection on a machine without ML expertise. So we do use that as an input for this workflow. So the prerequisite is to prepare your Sitewise environment with all your data and anomaly detection enabled, at least for one asset. So you have the anomaly result coming out of that asset, right? The anomaly score or some model explainability, right? So that's the starting point. Now, when you have an anomaly, So we show how you can create a workflow that gets triggered, and then that workflow can then automatically create a repair plan, right? So that your operations team can then take the repair plan and then go ahead with corrective actions, right? And we show how you can do that in an agentic fashion. Using 3 agents, we use Strands SDK to build these agents. And then when Chris talks about the second tutorial, we'll talk about agent core, right? So let me put down the architecture for the first tutorial. So you see pretty straightforward. On the left, we have site-wise edge collecting data from machines. So in this example, we use e-bike assembly line as the sample scenario. And we collect data from welding station, welding robots, and so on, conveyor belts. And then we'll use one specific asset, welding robot, to walk through the workflow, right? And then on the right, on the cloud side, you got site-wise cloud. That's where the data is modeled, assets are modeled, and data is stored securely. And then we show the agent workflow that's on the right that has a number of data sources. One site-wise, obviously, and then there is Bedrock knowledge base. So this is where we store all the manuals for that equipment. This could be equipment manuals, standard operating procedures, and so on. And these are all connected through MCP to the agent, right? And when the workflow is triggered, again, it's not one agent. Here it looks like we're showing it as one agent, but it's actually 3 agents working in a workflow manner. And then the workflow generates a repair plan when it's triggered, right? So the output is we generate a HTML report. We'll store it in S3. We'll give you a pre-signed URL so you can access the report, right? In real-world scenario, this could be a ticket that gets created in SAP PM or IBM Maximo. But here we're just creating the report and then putting it in S3. Yeah, that's a high-level architecture for the first tutorial. Any questions before we move on?
Yeah.
What's the trigger point from the site-wise in the middle to the predictive maintenance?
Yeah,
Do you guys have an algorithm that's actually running to say, I actually want to go to that? Or
yeah.
are you setting everything to?
So the trigger is an anomaly being detected in site-wise. So that's the trigger. So now you could define the threshold. We use 0.5 as a threshold for anomaly scores. So it's 0 to 1. Again, you can adjust depending on the criticality of your machine, but 0.5 is the default. So when we say there is an anomaly, that's when the workflow gets automatically triggered. Now we use IoT core behind the scenes for event-driven workflows from site-wise. So today, that's the recommended approach. So when there is an active anomaly in site-wise sends an MQTT message to IoT core on an event-driven basis, and then IoT core will trigger the agent workflow. Yeah, that's the flow today. But for this tutorial, yeah, we'll manually trigger the workflow, but that's how you do it in production. Yeah.
Yeah.
Can you repeat your
Your
question?
EC2?
Yes. So in this case, we are simulating data for that welding robot. So in fact, we have a physical demo that we showcase even at Venetian. There is an e-bike demo that you'll see. So what we did is we took the data from a physical demo, and then we're replaying the data using EC2, right? Yeah. But right now, the data for site-wise is coming through EC2, not through site-wise edge. But I still have site-wise edge there because that's the recommended approach. That's more cost-efficient way of ingesting data to the cloud, because it batches data for you automatically. Yeah. Yep, please.
Can I rip out site-wise and put something else there, but still use everything else?
Yeah, yes.
Yeah.
Is that just MQTT topic going in to actually communicate, or?
Depends on the triggering mechanism you would do in your pipeline to
Yeah, it's
drive
quite-
agent action, but it could be.
Yeah, it could be a Lambda, triggering as well. Yeah, you don't need site-wise. We're just showing site-wise as an example for the industrial data foundation layer, but it can be something else as well. Yeah.
All right. Great.
Okay.
So we're going to switch
Yeah,
over
can you
to
switch? Yeah, let's see.
demo.
Yeah.
All right.
Is it readable? Should I zoom in a little bit? Okay. So the repo that we're going to share with you. So here is a repo on GitHub, sample agentic code generation for industrial analytics. So what you'll see here, we're just going through this repo today, and we did all the prerequisites to save time for you. We have a QR code. We'll share that with you. We do have that.
Yep.
Yeah.
QR code
Sure.
at the end.
So what you see here is essentially two Jupyter notebooks. So under predictive maintenance, this is the first one.
Second one. Oh, the first one you're
Yeah, first one. So you'll see some prerequisites. So this installs the knowledge base, uploads the knowledge base documents. Again, one more thing to note is this repo is fully self-sufficient. So you don't need to know Sitewise, you don't need to know Bedrock. We prepare the whole environment for you. You can start with a blank account, AWS account, and then use this repo. We do everything for you from data simulation to preparing knowledge base end to end, right? It's self-sufficient. So I did the prerequisite already, so I'll not do it, but I can just show you. It's just preparing the knowledge base using Python SDK. And in the second example, so this is the tutorial for the repair plan creation using strands. So this is updated architecture, but it's pretty much similar to what we've seen earlier. You can see 3 agents working in a workflow pattern. And then we'll go through, I'll explain some of the highlights from this notebook. You can try it later in your own account as well. And then on the second tutorial, we got a separate notebook. This is for advanced analytics, so Chris will talk about this use case. So that's the repository to begin with. So I did a clone of this locally, and then I'm using Kiro. IDE. So I cloned this repo, and then I'm going to start with, so I have a virtual Python environment, so I install all the packages. Let me show you some dependencies here. So because we're going to use Strands SDK and Strands tools, so we have those installed already, and then we use YAML for some configuration, Boto3 to make certain calls to AWS services. So it's all installed. And now let me actually go through the tutorial. So the whole narrative, so whatever is the use case that we talked about around e-bikes, so it's all baked into the notebook, the whole scenario. I'll skip it for now. Okay, so I'll install the requirements. So as you can see, it's all pre-installed. So we'll import some modules. So to those new to Strands, so it's pretty important to look into these 3 import statements. So first, we're importing the agent, right? So this is used to invoke the agent once we configure the agent with prompt, system prompt, and the foundation model. And then tool, this is to create a custom tool, right, for your agent. So this can extend the agent capabilities beyond normal summarization, right? We use tool here to create the HTML or to save the HTML document locally to the file system. And then we use MCP client. So we have 3 MCP servers we're using in this tutorial. So we got MCP client to talk to those servers, and then we use Bedrock model, Anthropic model to tie it to the Strands agent.
Are people familiar with agents and tools and those terminologies? Like, is that something anyone needs more information on?
You want to do?
Yeah.
The expert.
So if you look at agents, think of it as going to be like a persona, right? It's going to be our maintenance person. It can be an operational person, right? And we're giving that agent or person tools to do their job, right? And those tools could be access to data, access to an API. And so when we say MCP and when we say tool, that's really the same thing. And then to confuse you a little bit more, an agent is also a tool. So an agent can have a set of tools, and a tool can be an agent, or it could be an MCP tool, which is access to like APIs. Right? Now an agent is configured with an instruction. That's what's different between tools and agents, is you define it in instruction and the tools it has, and you'll see that here as we configure these agents.
Okay. So we've imported the modules. So we have some configuration. So we need to pick the bucket where we will write the HTML report, and then we're configuring AWS credentials using a profile. So I'm pointing to a specific AWS account where I'm going to create that report into. And then, so Chris was mentioning the profile for each agent, right? So this is how you define the characteristics or the behavior of that agent. So we create those prompts in a markdown files. We call it SOPs, or these are system prompts essentially. So you can find them for each agent. So there is a separate markdown that explains the behavior for that, or the profile for that agent. So for example, for ops data collector, so this is the agent that collects data from Sitewise. So you can see the definition for that agent, including what it should do, a quick overview of what it does, and what's expected in terms of the sequence that the agent should follow broadly, and some constraints. So it's not completely undeterministic. So you'll find that SOPs for each agent. So we are loading those system prompts. So when we create agent, we'll tie this prompt, which is in the markdown file, to the agent. And then we are loading them. So I'll just run it to load the SOPs. So the next step is now we'll connect to the MCP servers, right? Now, let's take Sitewise as an example. You can talk to Sitewise in a traditional way using SDKs that we offer. But then now you can use Sitewise MCP server that we offer, and then plug your agent. So the agent can pick the right tool that's available to talk to Sitewise, both for reading and writing operations, right?
And this tool, there's a QR code at the end for this MCP tool.
Yeah, these tools are publicly available on GitHub. We have a bunch of MCP servers. There are some specific to a service. There are also some that are quite generic. There's a AWS API MCP server that can talk to almost any service. So we also use that here. So now we'll create MCP clients to talk to, because MCP is client-server based architecture. So we create MCP client to talk to those servers. And here, these are the 3 servers we are going to use, right? Sitewise MCP server to collect telemetry data for a period of time, and anomaly status, because that's all living in Sitewise. And then another MCP server to talk to Bedrock knowledge base. So this is where we retrieve the knowledge base details around that equipment from the equipment manuals and SOPs. And finally, the API MCP server. This is a generic MCP server. We use it to create a file in S3, right? So I'm not using a S3 MCP server, but rather a common API MCP. And then now we're going to create some helper functions to create these MCP clients. And when you create a client, you can filter the tools that you want to make it available for the application. So for example, let's say in Sitewise, you get about 50 or so tools part of the MCP server, right? But you don't need all the tools for all your agents, right? If your agent is supposed to just collect data, live data or historical data, from an equipment, you just need to use like maybe a fraction of those tools, right? So it saves you in terms of the response times, execution time as well. So we are filtering some tools from Sitewise in this case. So I'll show that in a moment. But then here, this helper function, all it does is it creates an MCP client for you based on the tool filters and the command that you provide, which is the identifier for the MCP. So I'll run this. Okay, so the helper function is created. And then I have one more to initialize the MCP clients. So this is where I plug in the environment. And then you can see I have 3 clients that I'm creating. So client number 1 is for Sitewise. And here is the identifier for the site-wise MCP server. And then I'm using specific tools, not every tool. I just need 5 tools to retrieve data from site-wise. Similarly, I got 2 more clients. So Bedrock knowledge base client. So here is the identifier for Bedrock MCP server. And third is for the AWS API MCP. So this is the common MCP server that I mentioned earlier. So 3 MCP clients, right? And then we are just returning those clients. So I'll execute. Okay, so it's done. So finally, so far we have created helper functions. Now we'll actually execute and initialize those 3 MCP clients, and we get back those 3 clients. Yeah, it just takes a minute or so.
So any questions on this configuration you're seeing, or something you might want to apply to yourself?
So just to make sure I understand, the site-wise client runs on the edge device.
On this machine, you mean, like, or where does a client connection occur?
Theoretically, not this.
Yeah. Yeah, so wherever the agent is running, which could be agent core's runtime as an example, it would be the client, and you would have to give it this authentication. But the tool is brought down to that agent that's running. Yeah.
Okay. So yeah, we are done. We have the clients created and connected to the servers. And you can see for each client, the number of tools available. And with that, let's move on to creating the agents, right? So we have the foundation ready with the MCP. Now, when you create agents, you can also define your custom tools. So far, we haven't created any custom tool, right? We're just using what's available out of the box from AWS, part of the MCP servers. So for us, in this case, just to show you how you can extend the capability of existing MCP servers for your agent, here we're creating a tool to store the HTML report that we generate locally, right? And then the report gets copied to S3. So this tool, all it does is it takes HTML as input and then stores locally. Now, to do that, to store a file locally, either you can use like a file server MCP, that has access to your file system, or you can do something like this, right? Create a tool that does a very specific task. So here, we are creating a custom tool. And the way to do it in strands is using the tool decorator. All it is a Python function. You add a tool decorator and it becomes a tool that's available for your agent, right? So here, this is a tool to save HTML file. You can see the definition of it. All it does is it basically saves the content to a file. So nothing special here. So I'll create that tool definition. Yep. So now we are done with the tools, right? We have all the tools, some through MCP, some custom. The next step is really creating those agents, right? So here we'll create some helper functions, again, to create the agent. So first we'll initiate the Boto3 session. So here I'm pointing to a specific AWS account using profiles. And then I'm also picking the Bedrock model, the foundation model that I'm going to use, right? So for this tutorial, I'm using Claude Sonnet 4. So you can change under the model ID. So this is a common model I'm using for all 3 agents.
And so with strands, you don't have to use Bedrock. You can actually use other types of LLMs in your choice. So that's an option.
Yeah, it's not tied to Bedrock. Yeah. Yeah, and then it helps you initialize those agents, as you can see here. And while creating agents, there are 3 things you need to note, right? So one is the system prompt, essentially the profile definition for that agent, which we created in a separate markdown file. So agent 1 is ops data collector, which is responsible for collecting all the data from site-wise. And we have system prompt. We are now attaching the tools that are available and the Bedrock model, right? The common model that we defined earlier. So that's agent 1. Agent 2 is your knowledge retriever. So the job here is to retrieve knowledge related to that machine. Here it's a welding robot from the knowledge base, right? So here we have a separate system prompt. So I can show you how it looks like. So the definition here, it says, is for a given asset, the SOP retrieves relevant information from Bedrock. Pretty simple. You can, again, fine-tune this. And then we have separate tools, right, from the MCP, Bedrock tools. And then we're using the same Bedrock model. And finally, a report generator, right? So the job here is to summarize and then create a HTML report, and then to copy that report to S3, and then to give you a pre-signed URL, which is a temporary URL that's valid for 1 hour, right? Again, in real world, this could be integration with your ticketing or asset management system, right? So that's pretty much it. So I'll create the helper function. And finally, I'll initialize the agents. So now, so far, we have created MCP clients. We created a custom tool, and then we've created 3 agents, right? It's creating. The agents part is still going on. It should take a minute. And we're almost there, right? The final step is then to execute the workflow. So 2 agents were created already.
Any questions while that's executing? Okay.
Okay. So yeah, we're done with creating the agents. So finally, now, yeah, we need to execute the agent, right? So there are some, like when you deal with multi-agent, right? Because here we're not just talking about 1 agent, there are 3 agents. There are different ways to design patterns for multi-agent architecture, right? And it's well documented in Strand's SDK documentation. Some common patterns are listed down here. There's swarm, graph, and workflow, right? It really depends on how it really depends on the order of execution that's best suited for your use case, right? If your use case demands a sequential execution of agent 1, 2, 3, which is probably the best fit for our tutorial, right? Then you can take a workflow approach. There is also a graph approach using a DAG. You can execute your agents in a DAG, following a DAG topology, or you can have autonomous coordination between your agents, right? You don't define the order. You leave it to your agents to decide the handover process, right? It can be agent 1 to 2, back to 1 to 3 to 2, right? It depends on the question. So again, it depends on really the use case. You can pick one of those patterns. So here we're using workflow pattern because all we need is a report following a sequential flow. So here is a helper function to create or to trigger that workflow. We have all the 3 agents, and then you can see the handover process, right? Because it's a workflow, we are defining the order. So step 1, we are calling the agent ops data collector agent with the query process anomaly for asset name. So the prompt here is to process anomaly for a single asset, right? Which is a welding robot in this example. And that goes to the agent 1. So agent 1 will come back with all the data from Sitewise for that specific asset, right? And then it will then hand it over to the knowledge retriever, the agent 2, right? In the prompt for this agent 2, along with the asset details, we're also providing the raw information gathered by the agent 1, right? So that's step 2. And then now you have also, in addition to sensor data, the knowledge information as well. Now we are feeding all that to step 3, right? And then the prompt here is to generate a pre-signed URL for the analysis, and then to store the HTML report locally, and then to copy it to S3. And then we have some parameters to point to the right location in S3. And that's pretty much it, right? So this is essentially the workflow. In Strands, there are new tools that will help you to manage workflow. You don't need to manually define a workflow. There are better ways to do it, but right now, this is one way to do it. So now I'll trigger this workflow. And now you can see the whole interaction between the agent and the MCP, server, right? You can see the tools that the agent is calling to get the relevant information depending on the prompt. So the first step is to figure out, to identify the asset, right? So we're asking the agent to process anomaly for a welding robot. So it has to figure out where that asset is in site-wise. So the first step is it'll really find the asset ID for that welding robot. And it does it by calling list asset models, list assets, describe asset. And then it found the asset ID. And then using the asset ID, it's making a batch call, because in the system prompt, we were explicitly asking the agent to use batch calls wherever possible. So it is using batch get asset property value to get the sensor data from the machine.
So it's really cool. The agent's able to look at the tools and know the order of which it should call, which API to ultimately get to that ID, right? Which is
yeah. And then now you can see the flow from agent 2. So agent 1 flow is done. It got back all the sensor data. So agent 2 is now retrieving the data from the knowledge base, as you can see. So it's doing a list knowledge base. It's picking up the right knowledge base to query. And then yeah, you can actually see the response from the knowledge base too. Yeah, it shows you a high temperature warning around 80 degrees for joint 0, and some recommended actions, including the error codes. So this error code is coming from a knowledge base document, right, stored in S3 through Bedrock knowledge base. And then some recommendations, like looking for obstructions and so on. And then it also did some analysis around the joint velocity to give you more insights, some risk assessment, some contact details as well from the OEM, again, which is part of the knowledge base. And then it's generating the report, and then it's saving locally. Let me show you how it looks like on S3.
oh, it's gone.
Just give me 1 second. I'll take a. Yeah, I'll show you a sample report while it's running. Yeah, so this is one I ran like 1 hour ago, or yeah. So what you see here is a report for that anomaly workflow, right? It gives you the live status of the machine, the results from the knowledge base. So like I said, the issue is caused due to high temperature and high velocity at that joint. So it gives you the error code mapped from the knowledge base, some root cause analysis from the knowledge base, action plan. Again, this can be formatted, right? You can fine tune the system prompt to format the report. That's possible. So yeah, you see the maintenance schedule, some warnings, contact details, and so on. So yeah, that's pretty much it. I wanted to show in this tutorial, like how you can start all the way from no agent to prototyping a multi-agent workflow to help you troubleshoot issues with your machines. Now, this is pretty much for prototyping, right? So when you are trying to move these agents to production environment, so that is where you would probably look into something like agent core, right? And where you make your MCP servers and tools more discoverable using agent core. Right now, we are doing all locally using strands. Really great for like prototyping in this case. So now I'll hand it over to Chris. So before I do that, let me give you a quick context, right? So in this tutorial, we processed one anomaly, right, in a operational context, in a live operational context. But then when you see anomalies occurring regularly, frequently for a type of machine from a vendor, for example, or a period of time, you may want to dig deep into what's going on, what are those common patterns, right? So that's where advanced analytics comes into play, right? So this is where someone from the operations team or a data scientist would actually go into and look into different equipments under the same equipment class, for example, to see what's causing those frequently occurring anomalies. So Chris will show you a different workflow that will help you do exploratory analytics, right? On, again, the same, it could be same machine class like welding robots, to look at a historical data set, right? Let's say last 2 years or last 2 months or 6 months, and to give you some common patterns that you can use and prevent anomalies from happening, right? But this workflow we saw is, let's say you have an active anomaly. How do you respond, right? That's what we're showing in this tutorial. But in the next tutorial, we'll show more on historical data analysis, right? That's where advanced analytics comes into play.
Okay.
Any questions before we hand it over to Chris? Okay. Good.
Great. All right. Thanks, Raju.
Yep,
Take
sure.
over. Yeah, so we're going to, like you said, go into some advanced analytics. And so we'll just kind of paint the picture. There's this trying to address the manufacturing skills gap, right? So the challenges that we have a need to access, data insights and really do this quickly without having to rely on external IT teams and data scientists to really analyze the big picture of why I have maybe an excessive anomaly that's being detected. So think of Sarah. She's a process engineer, and she sees that motor 01 is sounding off again, right? One of my joints is triggering again an issue. So with this, we want to show how we can use Bedrock Agent Core and first-party tools that it has, tools that we build and maintain to actually execute and generate code on the fly. So you ask it to do some analysis. It will start to pull NumPy and SciPy and all these other libraries used for data analytics and really start to take that data and bring it through a whole, even creating machine learning linear regression models. It's really pretty fascinating. You'll see what it does. So it looks up, you can look up equipment specs, you can look up other information you need in this process of analysis. And this all happens in a sandbox within that Agent Core environment. And so that's what Code Interpreter does here, right? It lets you execute and generate code securely. And you can do this on large scale of data, right? We're thinking like, could be gigabytes of data you might have that you want to take through this analytical process. And it makes it easy to use. You can execute code in JavaScript and TypeScript, Python, and other types of languages. All right, so that's what we're going to see. A process engineer will talk to the agent. It will then pull access from Code Interpreter and other data points to run that code and then store it in memory. So with Agent Core memory, we're able to actually store these conversations and these results. And then Sarah can come back and say, hey, I have a follow-up question, right? And essentially with memory module for Agent Core, you can create short-term memories and long-term memories. So imagine like you have this a lot of conversations that occur over a period of time. You might be able to create the semantic relationship between things, and it can recall that memory for you when you talk to it. All right. Let me go back to, switch to demo.
Yep.
Yeah. Okay. So we'll go to advanced analytics. I'll close out some things. Okay. So here's initial start here. We'll actually go ahead and install the libraries like we need, like before. So we won't have to go into that detail. We'll actually create this Code Interpreter module and instantiate that, and it's based on regions. So we support a couple of regions. I can't remember all of them, but we're going to use US East 1, which is Virginia. And this is part of the Agent Core libraries that we're using. So if you look above, there's actually this Agent Core Python library that we'll use for accessing Code Interpreter. All right, let's go ahead and load the equipment data that we have from the anomaly test that we did, right? We're seeing now we're generating excessive amount of anomalies, and we need to really do some deep analysis into that.
How many rows are in that data frame right there?
How many rows ended up in
1,000.
1,000?
We want it to be done quickly, so it's ready.
Yeah. Hit execute and we'll wait for 30 minutes.
Yeah, it's just 1 month of data sampled every minute.
Yeah, so you see several joint temperature, velocity, and various types of joints that exist in that robotic arm. And so we're trying to get through that. All right, that's done, right? Okay. We need tools, right? Helper functions. This is like you saw, we won't go into that detail again, but this is something that, Raj, you mentioned, right? You need some helper functions to open files and also prepare for the sandbox environment. So we're taking some of that data and putting it into a CSV into that sandbox. And then more helper tools, right, to be able to call that tool. So these are not that important, but writing and listing the files you have in the sandbox. So we're going to create that as well. Now here's the great part, right? The fun part, you're creating that agent's persona, right? So you're telling them you are an industrial IoT data analyst, analyst assistant, right? And so you're specialized really in detecting this equipment health and monitoring. And it gives you all these principles you have and the tools you might want to access. So you need to execute Python and see the output. So we'll go ahead and create that system prompt, which we'll use coming up soon. Now we want to create our tools. So I'm going to go ahead and create a tool for code interpreter that Strands will use. I'll create one for the equipment knowledge. So we'll create that as well. And then we need to enable memory. So in this example, you'll see it's actually, you don't want to use this code in production, but it's looking for the existing memory and it's like wiping it out, right? So you can start fresh. So you don't want to be wiping your memory every time this thing runs. But it just kind of gives you an example how you can set up your memory and create hooks. So with Agent Core, you can create this hook where every time there's a response, the hook triggers and it takes the memory and stores it. So that's what we're doing in this code. And so if we go down to the bottom, you'll see that it's found that existing memory, right? Well, it's active. I'm cleaning up your old events, deleted 18. Memory is now ready for fresh analysis. So just be aware of that, right, when you're looking at this code. Now, with strands and agents, you need to now configure that to be aware of the memory module. You need to be aware of the tools it has. And so that's what we're actually configuring here, is configuring the model to use, the memory hooks that we're going to have for the memory module. And then this line of code, we want agent with memory. So we create that agent, we specify the model, the tools it will have, that system prompt, the hooks that will then trigger the memory module to be used. Any questions on that line? That's an important line, right? Because you're actually like really setting up the agent's capabilities. Okay. Now, one more helper function for displays. We'll go ahead and run our first analysis. And that's probably the time we'll have. There's actually more follow-up questions we can do to really test the memory. But we're going to actually run this example where the welding robot has several anomalies lately. And we want to understand what kind of overall analysis you can perform on that data file. So let's go ahead and run this. And I'll minimize this code. Let's see. So look what it did, right? Code, generated code, import pandas, import numpy, import matplot, right? It's actually like a data scientist creating the code that it will use to do this analysis. It starts creating its own plots, right? So I'm going to create this scrollable so you can see. This takes about a minute and a half, right? So as you see it create, the different graphs for anomalies, different lower and upper bounds. These are things I don't know myself, right? I'm not a data analyst, but really gives you the power of, oh no, what happened? Okay.
I think it's a throttling issue.
Might be.
Yeah, we are limited to how many calls we can make to Bedrock
Right.
model during this week.
Yep.
Yeah, you could hit again. Yeah, hit again. Yeah.
We'll give it a second chance. Yeah, this is a lot of usage on Claude, for sure. But it gives you an idea. You'll be able to execute this, hopefully, as well. If this fails again, hopefully it doesn't, but you'll be able to execute this on your own and see the results. Okay. All right. Well, what would you see is essentially just as a result, it would have it would actually show the correlations between these different anomalies and different sensor issues, and be able to tell you that, oh, okay, this is something you need to perform a repair plan on or perform more scheduled maintenance against. And so there's different types of advice it would give that's really helps you create that direction on how you can optimize your equipment. Maybe there is specific specifications or settings that you need to adjust to the machine specs. So it's really cool. It gives you a whole report. I wish I could show you that end here.
Yeah, you want to try one more time?
Sorry, one more time? I have a video. I'll back to you.
Yeah, let's pull out the video and see if it works this time.
It's like the meme where it's like, sorry boss, props down, but I ran out of token.
Yeah, I know, right? Yeah, no, it's like Claude gets hit a lot during reInvent. So it's all these workshops and.
Yeah, but you can already see the analysis right in the print statements, right? So it says there's no strong correlation between sensors. So it's trying to print into a report. Where it's failing is generating that report, but the analysis it's already being done. You can see the distribution of simultaneous analysis. You can see that it's finding the common patterns, the baseline behavior for certain sensors.
Yeah.
And also the data quality. It also checks that missing data, gives you a data quality report, which could be causing maybe false positives as anomalies in site-wise. Yeah, that's another insight you could get out of this advanced analytics report.
Might get lucky. Third time's a charm. Any questions while this executes? We've got 3 minutes left, so that's your chance.
You want to show the console maybe in the meanwhile? The console?
Oh, yeah.
What does production look like at scale?
For this type of solution, and you're providing it for the analysis point of view? Like just the advanced analysis, yeah. So you're giving that access to
Like in my environment, I have 350,000 devices.
50,000 devices. I mean, whether you perform it across all those, right? You trying to look at it holistically as an issue that might be occurring across many devices and sensors.
It's more like this right here, like how does this scale out? I mean, even if you take like a manufacturing plant, you're going to have 500 to 1,000 devices inside of a single manufacturing plant.
Mm-hmm.
So like from a production perspective,
Right.
are you heavily reliant on site-wise to be able to actually go and pinpoint what gets sent into here and so forth?
Yeah, it leaves that up to the human to decide some of those things, right? Like it's as opposed to like giving it all the data points and saying, make sense of this, right? If there's a particular operation or process area that you're looking at and you're trying to address potential issues, then you might be able to narrow your scope.
Yeah, but from a data management aspect, SiteWise is fully managed. It's highly scalable. So we have customers using SiteWise for thousands of assets. They onboard those assets, and then SiteWise can scale even in terms of anomaly, giving out you those anomalies, detecting and triggering event-based workflows. That's highly scalable through SiteWise because it's fully managed for you.
So it actually ran for a time.
Yeah.
So we see critical issues found, right? Joint 0, urgent attention required. We see 27 extreme temperature anomalies reading up to 87 degrees Celsius. And so it shows this like correlation between the joint temperature and velocity anomalies, and really starts to break down these issues, right? It also looks at what are normal operating ranges. And
This had nothing to do with manual, correct? Like no knowledge base on this?
there is some specs that it pulled from the machine to know these are my operating ranges.
Gotcha.
It looks at the data points, correlates that together, creates all that code to perform that analysis and create those plots like you saw in the code.
I mean, the more context, the better, right? So in this case, it's just the sensor data and the knowledge-based documentation. But you can bring in more MCP servers to talk to more systems. You get a better analysis.
We also said like we intentionally made some data missing and it detected that too, saying, hey, I see data quality issues. 67% of this missing across joints, and so that's. I saw your hand up there. Yeah, what's your question?
How would you curate the knowledge base? If you found something that was making problems with manual, how would you make sure that it's going to pull the new information that you found rather than stuff from manual?
Right, by updating your index, and so there's a mechanism to go ahead and update your embeddings. And
Do you want the rest of the manual stuff? It's just like one bit of it, that joint temperature range is a typo or something.
you want to only update part of your embedding. Oh, okay. That's a good question. If you identify the chunk where that's you extract that from. But that's a good question. I need to follow up with you after and see how we can do that. But yeah, gives you a full report of what you need to do and maintenance recommendations.
You can further enhance it to show like plots. So we're not showing plots here. You can do pairwise plots, correlation analysis. You can do scatter plots, and all that part of the workflow. We're not displaying. We're actually doing it, but not displaying.
Great.
Yeah. Oh, we have time.
Any questions on what you've seen? Go ahead.
Yeah. Let's
Give you
do the
QR codes.
Yeah. The first link is to the public repo, and you can try it in your own account. And the second is the list of MCP servers. I think we're pointing to site-wise MCP, but in the same GitHub repo, you'll see all the MCPs that we provide to talk to a number of AWS services. And third is some examples to get started with Agent Core to really scale your agents to production, right?
Yep.
So.
Awesome. Well, thank you. Thanks for joining our session.
Thank you.
Appreciate it.
Thank you all for spending time with us. Thank you.